Hello, I'm Nayeli Mendez Cervantes, and this is my presentation for my research paper on the discovery of the ozone layer. So I'm just going to be reading off my research paper. The ozone layer is 6 to 31 miles in altitude of the stratosphere that protects all life forms. Without it, life on Earth would not be possible. Ozone itself is a combination of gases, including volatile organic compounds, also known as VOCs, and oxides of nitrogen, known as NOx, and heat that absorb harmful ultraviolet radiation from the sun. The ozone layer acts as a sunscreen for the Earth, blocking all direct ultraviolet radiation from the sun. The ozone layer itself is not harmful, but it becomes harmful when it becomes too thin and when it is ground ozone. The history behind the discovery of the ozone layer is extensive. It includes what harms the ozone layer, what ozone holes are, and the protocols and laws put in place to protect it. Ozone was discovered in 1839 by Christian Friedrich Sean Bain, who noticed a strange odor was produced during thunderstorms, and it became known as electric smell. Sean Bain was able to produce that electric smell during an experiment in electrolysis of acidulated water, which later became known as ozone. Human activity has worsened the state of the ozone since before the 1980s. Measurements from satellites, aircrafts, among other instruments have reported the number of ozone molecules occurring per square meter decreased globally, around 5% from 1970 to mid-1990s. The biggest decline in ozone occurred in high latitudes, so towards the poles, and less in the lower latitudes, in the tropics. The reason why the largest decline occurs in the poles is because of the freezing temperatures. A polar vortex circulates and isolates the air in the ozone hole. It becomes so cold that it is able to form clouds, and then chemical reactions begin to take place. Then when the sunlight comes back, the UV light breaks the bonds in the cloud, releasing the chlorine atoms into the ozone layer, where it destroys the ozone molecules. The atmospheric measurements proved that a decline of ozone layer increased how much ultraviolet radiation was reaching Earth. Evidence of human activity making the ozone layer worse has been available since the 1960s. During President Richard Nixon's administration, it was revealed that the water vapor from aircraft's engine altered and caused damage to the ozone layer. Aircrafts released nitrogen oxides, which allowed solar radiation to penetrate deeply into the lower atmosphere, causing dangerous health problems for many people at that time. The discovery of ozone came from an experiment, and from there only the best chemists among other scientists researched about it back then. Discussions and debates about ozone, investigation methods, and theories lasted for decades, while this discovery also brought on political debates and conflicts as well. Each error or accurate finding moved the discovery of the ozone layer forward, but something that eventually caused a pause in their investigations was that the scientists were only using one mathematical model for a long time. This created problems because all chemists and scientists resulted with miscalculations and theories that were not plausible. When people heard about a hole in the sky, many were frightened and blamed the government, aircrafts, and shuttles for the destruction of Earth that was to come. Eventually, it was known that hole in reality meant an extremely thin patch in the ozone layer. At some point in the 1960s, a professor at the University of Arizona suggested that UFOs were the fierce enemy of humans and caused damage to the ozone layer. The UFO rumor may seem extreme, but given the time back then, people already didn't trust the government or scientists. It did not seem that outrageous to them. A significant and increasing problem is the thinning of the ozone layer in recent years. The depletion of the ozone layer is caused by the release of chemical compounds containing gases, chlorine, and bromine from industry and other human activities. Once the chlorine and bromine atoms come in contact with ozone, they destroy the ozone molecules, or only chlorine can destroy 100,000 molecules of ozone. Another chemical contributing to the destruction of the ozone layer are chlorofluorocarbons, or CFCs. that contain elements of carbon, chlorine, and fluorine, which are commonly found in many household items. Some household items containing CFCs include refrigerators, aerosol cans, foam cushions, packaging materials, and many plastics. Since CFCs are extremely stable, they can deplete stratospheric ozone for 50 years or more. Thinning of the ozone layer has become evident over the years due to the holes forming in it that are allowing ultraviolet radiation to flow directly through it. The belief that there are holes in the stratosphere is a misconception. They are not holes, they are only extremely thin patches of ozone. The thinning of ozone affects humans, animals, plants, and ecosystems. Humans exposed to ultraviolet radiation due to thin ozone patches results in serious health issues, such as skin diseases, cancer, sunburns, cataracts, quick aging, and weakened immune system. In addition, people with existing health problems like asthma may experience shortness of breath or even more severe respiratory issues. Ozone is a powerful oxidant where in high concentrations it can specifically irritate the throat and eyes, lead to bronchitis, bronchopneumonia, and produce asthma attacks. This exposure to ozone can also lead to heart disease and strokes. Animals are affected in similar ways. They can also experience skin and eye cancer. Exposure to direct sun radiation on the environment can lead to serious consequences. The environment can experience minimal growth, blossoming, and photosynthesis in plants. Some signs of ground ozone affecting plants can be flecks, there's small tan specks, stipples, medium-sized dark pigmented areas, and bronzing and reddening of the leaves. The ozone enters plants through the stomata and causes oxidation to take place during respiration. Ozone symptoms for plants typically happen between veins in the upper leaf surface of older or middle-aged plants. The type and severity of symptoms depends on exposure duration and concentration of ozone, in addition to weather conditions and plant genetics. There was a study done on yield loss caused by ozone. The most extensive research was done from 1980 to 1987 in 5 different locations in the US. The focus plants were agronomic and kept in chambers, exposing them to ozone treatments. Evidence of significant damage of ozone showed dicot species were more sensitive to yield loss than monocot species. Some laws and protocols have been placed in order to recover the ozone layer and maintain it balanced. There are many programs and laws that have been created by the government. However, there are also steps that can be taken at the individual level to protect the ozone layer. One solution would be to stop or avoid as much as possible the use of pesticides that are made with several toxic chemicals and instead use natural methods. Eco-friendly chemicals are available to get rid of weeds, or one could do so manually. Minimizing the use of personal vehicles since they emit a large amount of greenhouse gases that also damage the ozone layer. The United States has implemented the phase out of ozone depleting substances, or ODS. It has classified ODS as 1 and 2. Substances in class 1 are chlorofluorocarbons, CFCs, and halons, which have higher ozone depletion potential that have been phased out, meaning nobody can produce or import class 1 substances. Substances in class 2 are hydrochlorofluorocarbons, or HCFCs, meaning substitutes for class 1 but have been mostly phased out as of 2020. There are only a couple left in use today for air conditioners and refrigerators. The Environmental Protection Agency, or EPA, has issued some regulations about reporting and record-keeping requirements for producers, importers, and exporters of Class 1 and 2 substances. EPA provides the forums and webinars to connect with businesses and provide additional information. Another solution provided by the government is under the Clean Air Act that they have called SNAP. The purpose of this program is to evaluate human health and environment risk of both existing and new substitutes of ODS. SNAP is also responsible for publishing a list of acceptable and unacceptable substitutes, promoting acceptable substitutes, and informing the public about the potential risk of environmental and human health impacts of the substitutes. Some of the enforcement tactics used to make sure rules and programs are being followed range from civil fines to criminal prosecutions. Enforcement is provided by the EPA. Some penalties of purchasing or possessing CFCs or HCFCs is the immediate confiscation of those substances. They may become a target of investigation for Customs Services and the EPA and the Internal Revenue Services. IRS could decide to investigate payment of taxes on CFCs, too. An example of EPA enforcing their rules is on August 7th, 2020, the American Fire Technologies Company has agreed to pay a penalty of $57,397 for importing 2,825 kilograms of used halon, a Class 1 ozone-depleting substance, without prior approval from the EPA consistent with the petition requirements. EPA could also take it as far as shutting down a company or any business not abiding the laws time after time after time. Overall, the ozone layer has been thinning for decades, since before the 1960s, and the investigations about it have been going on for some time too. But the science, knowledge, and tools back then were not nearly as good as they are now. Back then, all their studies set the foundations for people in the future to further advance scientific knowledge. Ozone holes affect all life forms, from humans to animals to plants and bacteria. High ozone levels cause several varying health issues for humans and animals and can limit agriculture productivity. By limiting productivity, it creates an imbalance in the food pyramid. There are also a few steps individuals can take to help protect the ozone layer, such as stopping the use of pesticides and reducing individual vehicle use. The government has also created many laws and programs in an attempt to fix the thinning ozone layer, and the EPA has provided ways to enforce the ozone protection. The gradual and continuous studies of the ozone layer, along with other science concepts, has allowed science knowledge to advance and understand the measures needed to protect Earth and all of life.